Should you go with a Cat 5e, a Cat 6, or should you abandon copper and go with a fiber cable? Stick around as we identify the different cabling standards.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in to more of the Cisco Certified Technician routing and switching. That's right, we're identifying Layer 1 and Layer 2 technologies, and for this, it really means cabling. What are some of the goals, Ronnie?
You know, when we talk about the goal for this, we want to make sure that we understand that, hey, cables look all the same, pretty much. But behind that, though, the technology is actually a little bit different, and it can actually mean the difference between whether or not you're actually getting good performance or whether you're getting poor performance as well. And also, you might actually also need some specialized cabling. Sometimes you may also have to deal with fiber optics, and how do you actually handle all those? So we want to make sure that you have a good experience and actually understand, at least at the beginning, of what it is that you might encounter in the field and what it means that you actually have to kind of look at these things a little bit closer than just saying, I just need a network cable, okay?
Yeah, Ronnie, you know, one of the things I think of is the fact that probably the most prevalent LAN technology in the last 40 or 50 years has been Ethernet, and it really started out with copper communications. Is that where you might want to start, maybe with some of the copper cables?
Right. So when it comes down to it, remember that when we talk about it, you might hear the term media more than anything else. So in networking today, there's actually a couple of different types of media that we tend to use. One, of course, is fiber optics. We're going to talk about that briefly, but by far the most prevalent one is one that Wes mentioned, which is going to be copper cabling of some sort. And the most conventional copper cabling that we use in networking is what we call twisted pair cabling, and technically unshielded twisted pair cabling. And there's 8 particular conductors that are wrapped into 4 separate pairs, and they're color-coded, okay? We're not so much worried about the color coding, but they are pinned out in a particular order on these cables to ensure that they work a certain way, okay, that they need to. And the reason behind that, Wes, let's talk about that just for a moment here, okay?
Sure.
About the idea of pins and what actually ends up being used a lot of times, okay? So when we start talking about that idea, Wes, okay, so since there's actually 8 connectors, there's going to be 8 separate pins for us when it comes down to individual connectors, like we tend to see right here. Let me try and make sure that you can actually see that a little bit more. So when you actually start talking about that, each one's actually lined up, and that is because we do what we call sending and receiving, right? Okay. So when it comes down to that, those pairs, one pair sometimes is used for sending, and the other pair is used for receiving, and that goes directly to the hardware itself. Now, when you start getting into higher speeds, you might actually use more than that, but at least at the most conventional level, you actually hear that there's a sending pair, that there's a receiving pair that we have too.
And the twist, if I understand this right, Ronnie, in the twisted pair cabling that you're talking about, that helps to, the amount of twist, I should say, in the cable help to increase its resiliency against things like electromagnetic interference, right?
Right. So, yeah, when it comes down to the cabling, the longer the cable gets, the more interference is going to happen. So adding in the certain number of twists that there is per whatever the length is actually does help to mitigate against a lot of that interference as well. All right, so Wes, I have 3 different copper cabling wires here, okay? Now, when I look at them, they look all the same. What about to you?
Oh, I can tell the difference, the colors.
Yeah, the colors are exactly
Doesn't
different.
really help though, right?
Yeah, and that really doesn't help. So, Wes, if I end up taking something like this and go, you know, I lost that one, and I go and replace it with this, I might think that everything's good and it actually works until you actually take a look and realize everything is working, but you have actually kind of slowed down your network as well. And that's when you have to identify them by something else. And Wes, we call that identification, of course. We do it by standards,
That's right. Category standards.
Yeah.
Sure.
So let's talk about those categories just briefly here. All right. So Wes, when I actually need to identify a category, how do we identify that on something like a cable?
Well, if it's a vendor-specific cable, and actually one that you're making, a lot of times what you're going to see is on the outer jacketing, the insulating jacketing, there's usually a little bit of print on the outside that'll let you know what the cable is. Now, if you're buying this where you're going to make the cables yourself, the same thing is still true. Along the outer jacketing is usually where you can tell that they've printed on there what the cable standard is so that you can also determine what its capabilities are.
All right, so Wes, I actually see this one that says Category 5 patch cable.
Okay.
So what can we learn from just knowing the Category 5?
Sure. So Category 5 is, I believe, what we call fast Ethernet, right? And fast Ethernet means that just by Ronnie telling me that, it should have a you could sustain bandwidths of around 100 megabits transmission speeds. And again, a fast Ethernet being the standard that's associated with that copper cable. So we can get a little bit of the characteristics just in our minds if we're familiar with that standard, what the capabilities of that cable would be and what kind of performance it should be giving us on our networks.
Yeah, so that one, fairly standard, but what if actually take a look at this one? And Wes, I took a look at this one a little bit earlier. This one says Cat 5, but it actually has an E after it. Is that any different than Cat 5?
I think that's Cat 5 Extra. No, probably not. I think what that stands for is what's known as Cat 5 Enhanced.
Okay.
And at a time where the technology was progressing out of had already been out of the 10 meg standard into the 100 meg fast Ethernet standard, you started to notice that devices were being created that needed a lot more bandwidth, and potentially into what's known as gigabit Ethernet. So gigabit Ethernet starts at Cat 5. That means it has the potential to get around a gigabit transmission speed. Now, that's always going to vary based on the link, so we do have to be careful with that one, because technically you should get a sustained speed of around, I believe it's around 350 megabytes.
Yeah, megabits.
Megabits,
yeah.
Excuse me, not bytes, bits.
Yeah. Now, with that, in theory, they say you can get up to a gigabit, but really it's not really certified for that. Now, Wes, this one says Cat 6 on the printing. So what's the difference then when we start comparing them?
So I believe at Cat 6 level, now what we're doing is we're getting a sustained speed, a certified speed of a gigabit versus the Cat 5e, like Ronnie said, well, may or may not give you that, never been certified for it. I think this is when we actually get to the certified gigabit speeds and it can stand gigabit networks.
Yeah. So, Wes, if I were to take out a device and then I took this cable with me, and then in the end, somebody called me and said, hey, I had this yellow cable here and it says Cat 5. Can I put that in place? Yeah,
Sure,
I can.
sure.
But what might be some of the consequences that we've talked about?
Oh, first of all, I would think that if you're putting, a non-gigabit, let's say the Cat 5e, or maybe even the fast Ethernet, at Cat 5 in a gigabit network, I would think that you've just kind of bottlenecked, crippled your network in the fact that your devices can handle, and maybe your sustained bandwidth out to the internet or whatever, can handle a lot more speed than what the cable is actually capable of tolerating.
Yeah, so we want to make sure that we're very careful with that. If we are replacing something and it says a Cat 6 cable, my recommendation, and I hope Wes's recommendation is simple, make sure you replace it with a Cat 6 cable. Can cables break? Yes. Can they actually be rolled over by a chair sometimes? Can they be bent or tied in a way that you don't expect them to be and cause some interference to them? Yes. So if you need to replace a cable, make sure you always replace it with at least the same standard there. Now, those are fairly durable cables, though, okay, when it comes down to it, but they are limited by length. Most of them have that standard limitation of about 100 meters is what you can run them, or 328 feet. But there are cables where you can actually extend the signal a lot further, but we're no longer now using electricity, over copper. We are now actually going to be using what we call fiber optic cables as well. Now, Wes, I have a yellow one. And I have a blue one. Wes, once again, I mean, what?
I think we're going to have to look and see what Monoprice actually kind of stamped on that. And this is just a specific vendor, not a standard on it, that we're going to have to find out what they stamped on that cable, or we're at least going to have to check our receipt and see what we've actually purchased.
Yeah, so a lot of times you'll actually still see the standard actually printed on side. Now, this one is a little bit of an older cable, and they actually followed a different standard in printing here. And what they actually showed here is actually a 9/125, which means the core is 9 microns over the overall diameter of the
cladding,
the cladding and everything, which is 125 microns in its thickness and everything. Okay, so this one, even though we might actually think, hey, this is going to be what is called a multi-mode fiber, this one is actually still what we consider a single mode fiber, which actually is a longer distance that we can run these things when it comes down to the basics and what's happening.
Much more concentrated signal, just firing that electrical, or not electromagnetic energy, like Ronnie said, that optical light source, like a rifle shot directly down that highly concentrated core, which is really just one of the longest cables that we can have, some of them going upwards of 40 kilometers. Think about that. That's 40,000 meters. That's a pretty long cable when you look at single mode fiber. And then we also have the other one that we talk about too, right? The multi-mode fiber.
Yeah. So this one actually is listed by a different standard. It says OM3.
OM3.
This one is actually listed as. And this one is actually going to be, OM3, so that's a regular standard here that actually is situated for so much of gigabit of bandwidth that it can actually handle on there. So for us here, this one, I think, is actually a multi-mode fiber. And I can tell by the standard here, it is the 50/125, which tells you, again, the micron is at, or the thickness of the core is a lot thicker than what we had in this other one over here as well. So this is also what we call multi-mode. Now, just very quickly, what's the difference between multi-mode and single mode?
Sure, the way they propagate the signal. Again, it's all going to be that optical light source, but the difference here is if you have the 50 or the 62.5 micron, we have a larger micron, a larger core there. So there's going to be a little bit of signal loss, and it's going to use total internal refraction, basically to bounce the light source off of the cladding as it makes its way to its endpoint. And because that core isn't as concentrated as single mode, we're reducing the overall length of the cable, and I think it's going to be just around 3,000 meters tops and then under.
Yeah, and the single mode actually goes a lot further.
Sure.
Okay? And the other difference is the source of the light is also key here. With multi-mode fiber, you'll see it's a high-intensity LED lamp that's actually going to be that way, whereas with single mode, the laser is actually going to be the source as well. Now, Wes, I can't just plug these directly into every switch that's out there, okay? Some switches, like what we'll actually see a little bit later on, is that they'll have special ports for them, but even with those special ports, with the connectors that are actually on these types of fiber optic cables, here's one. This is a little bit smaller. It is called an LC connector, which stands for a lucent connector. So a lot smaller. And then this one has actually separated out a little bit. You can actually tell even the differences in terms of size. One's a lot thicker and one's a lot larger than what this connector is going to be.
And Ronnie, if I understand right, I've heard a couple of stories on that, and that's the fact that in the earlier days, fiber, which is still expensive, but by when it first came out, like you could see $1,500 just for a single port on one of these switches here. So the port density there wasn't really a lot of necessity to have more of these ports in a single switch just due to the sheer cost. But then as that cost has come down, we're kind of transitioning more, or have been for a while, to the LC connector, right? Which, if I understand right, gives you a greater port density, meaning more devices connected to your switch.
Right. So there has to be some way that we can actually get that to connect to our switches. So Cisco built in some special ports, but it also means you need something like this.
Ah, okay.
So this is what we call a transceiver of a sort in terms of generic. Now, all of them will actually be marked with different standards on them as well. So when you actually take a look, like this one says 1000 base-LX. And that essentially just means, hey, here's a different standard. And I have another one that's actually designed for that little bit of a thicker one. And this one is 1000 base-SX. They do mean different things. If you are replacing these, once again, make sure you replace them with the same standard that is already there. Even though these kind of look almost identical, okay, one has a little blue thing, but this one, it looks like you either lost it or didn't actually need it overall, okay? So one has that, but it doesn't mean that they're exactly the same, so be careful with these. So this is what actually, when we talk about layer 1 and layer 2 technologies in terms of identification, a switch is a layer 2 technology, okay? We saw that in our OSI show, but on this thing here, okay, this is actually what connects, and this is now what makes that cable, which is only transmitting light. This is what interprets that light. In other words, it actually gives it some form that makes it actually a layer 2 technology as well. So kind of see that. Now, on the other end of this, like we were talking about, there's another form factor. This is called I always get this wrong, SFP. I always say SPF, which is a suntan rating, suntan lotion rating. But this one right here is going to be a 10 gig SR. So we go from 1,000, 1,000 base, which is a gigabit.
Yeah, sure.
Gigabit, and this one is 10 gigs for this little tiny connector here, and they again just plug right into this thing too. So you actually have those ports, and that means the switch has to also be rated to also have a 10 gig port as well. Switches can have different ratings on those ports in terms of the bandwidth that they have, 10 gig or gig. Some of them have 100 gig. Some of them have, heck, 400 gig ports on them for data centers as well. So you name it, they're all actually out there. And you, of course, would need those same transceivers that would actually match whatever that standard is going to be. All right, Wes, so those are kind of the most popular ones that we see. But as a technician, though, you may also need to have some special cabling, too. And let me grab those cables as well. I probably dropped one, which I did. So, Wes, let's go ahead and start by taking a look at this. All right, Wes, Here you go. I'm going to
All
hand you
right,
that
I'll hold
cable.
this one, yeah, sure.
And you go ahead and does that look familiar to you at all?
Kinda. I'm taking a guess because this is a serial cable, and I haven't seen one of those in the back of a PC for a while.
Right.
So my thing, I'm thinking this is maybe a console cable of some sort, maybe
Right.
for configuration.
Yep. So yeah, that would actually be a very old console cable, but that's
Sure.
a regular standard RS-232 connector.
Oh, the no
That's a
modem cable,
9
okay.
Yep. And you look at the end, it's got that DB9
Sure,
type of
right here.
connector on the very end there.
Yep.
So you can actually configure a device using that, and then on the other end, you'd plug that into, well, a regular USB port, and you would just need some type of terminal emulation that would allow you to connect. Now, on
Sure.
the top of that thing, you can
Yep.
even see that there's some lights that can kind of flash on and off to show you whether or not signal is actually being sent.
Okay,
A
I
little
see
bit more of an
TX
advanced
and
one.
RX.
Yep.
This is that transmit and receive you talked about when we first started this episode.
Yeah.
Okay.
So that can actually end up being used. A lot of times you actually see that some of those devices, like firewalls even, they may have a plug like this that you can
Okay.
go ahead and directly console into like that.
Okay.
All right, so Wes, go ahead and put that one down, and
right.
let's
All
see if you
right.
can identify that one there.
Oh, well, I'm seeing some kind of console adapter here. This is a flat cable. My guess is this is a rollover cable?
It is a rollover cable.
But
Yep.
it's still console, a little bit newer because there's a lot more Ethernet connections on devices today. But it seems like this might also be for backwards compatibility on maybe some that don't have the Ethernet port but still have the DB9 connector here too. So it's looking like this is kind of bridging the gap between the old and the new.
Right. So that's normally the type of cable that you get with a Cisco device as you purchase it.
Okay.
So that is a Cisco console cable, but it is an older cable today. The end with the RJ45, we didn't really talk about connectors so much.
Sure.
But that particular connector right there plugs right in just like a telephone jack
it's
plugs
flat.
over there. But the cable itself is flat, and the actual wires in between, as you take a look at the actual connector,
Sure.
you'll see that they're actually different. There's not a striped pair, as well. They're
Okay.
actually flat in line.
Looks like we got all the colors in the rainbow here.
Yep. So we'll actually see that. Now, that is designed for the same thing, is that you would actually end up plugging that end into the console port on a Cisco switch of some sort, and then you'd plug the other end into the back of your computer that used to have an RS-232 connector, like you see. But you'll see that I also have an adapter there as well, okay? And that is to allow me to plug into a laptop.
Sure.
So it was a USB adapter to an RS-232, which plugs into a console port as well.
Okay.
So all that, probably something that you're likely to actually end up with at some point if you're going to be a Cisco technician.
And I can see that if you've never seen these before and have no clue, you would have said, oh, that's just an Ethernet connection, standard network cable, and it looks a little different. It's flat, but should be the same thing, and then a USB connector. So it's important to understand what's going on inside this cable.
Yeah, so when Wes talks about the idea of a crossover cable, that means that the one pair that's actually pinned from pins 1 through 8 on one end is actually technically crossed over, or rolled over, excuse me, where pins 8 through 1 are the exact opposite is what's happening here.
Interesting.
So it really is doing that. All right, there's one more, Wes.
All right. This is the bane of most people's existence that have ever used USB. This looks like a USB Type A to, let's see, where is it? Wait for it. Oh, okay. I think I recognize this one. That's a little mini USB connector there too. So I see the standard standard USB connector. Type A connector, we call it standard usually a lot of times connector, and then it looks like it's going to a mini connector on this side.
Yeah, so I call that a specialty cable, but you
Sure.
don't see anything special about it, do you?
No, I really don't. In fact, without putting it under a microscope after you cut the guts open, I wouldn't be able to tell any
Yeah,
different.
there really isn't any difference. So today, a lot of the newer Cisco devices, instead of having to have a special cable for it, they've said, look, let's go ahead and standardize this, and now they have a single console port that actually does plug that mini side directly in, and you don't actually need to have a piece of special equipment with you. So that means even if you do like I do sometimes forget my console cable,
Okay.
now I can just say, hey, do you have one of these connectors that was for, a telephone or something else here?
Sure.
And I can actually use that. So I can pretty much use whatever's on hand to directly console in and manage a device if I need to.
Well, I'll be sure not to throw some of these away because I typically have been, because just given the fact that we're in 2020 here, we're using things like micro USB and even USB-C today. So I'll make sure that I hold on to a couple of these for sure.
So the specialty cables that we talked about, the fiber optic cables, the regular copper cables that we talked about with the RJ45 connectors and everything else, These are, again, more typical of what you're likely to see when you actually go out into the field, and you should be familiar with them as well by their standards and their particular capacities as well. So make sure you take the time to look over these because they are not all made exactly the same.
All right, ladies and gentlemen, that's a good place to wrap up. Remember the key takeaways for this episode, and also remember that we've got a lot more coming up in this series. We're really only scratching the surface in the CCT Routing and Switch series.
Thank you for watching IT Pro TV.